Today we are moving to a new chapter, that is chapter 8, Algebraic Expressions. In this chapter we will learn what are algebraic expressions, what are their properties, and some of the operations using algebraic expressions. All these kind of things we are going to learn in this chapter. First of all, let us understand what are algebraic expressions. The algebraic expressions are mathematical statements that contain two types of symbols. They are constants and variables. So first of all, let us see what are constants. Constants are values or the symbols that can never change their values are known as constants. For example, examples for constants: 5, 6, 0, -1, 2/3. All these values are constants because you know that they can never change their values. Now, algebraic expressions also contain variables. Now, what are variables? Variables are symbols that can change their value or that do not have a fixed value, that its value can be changed, or they can take different numerical values according to the given situation. So, variables, example, we take variables with the names of x, y, a, b, etc. We use these letters for this kind of letters, or any letter in the alphabet we use for representing the variables. So algebraic expression contains two types of symbols or quantities. They are constants and variables. Constants have fixed value, they never change their values. Variables can change their value, or variables can have different numerical values. Now, since the variables are also numerals, variables can take different numerical values. They also obey all the laws as the other numerals or other numbers obey. For example, we can say x plus y is equal to y plus x. This is true for all the variables. What is this law known as? This law is known as commutative law. X plus y is equal to y plus x. So, commutative law is obeyed by the variables. Now, x plus y plus z is equal to x plus y plus z. That means this is associative law. Associative law is also obeyed by variables. Now, x plus 0 is equal to x is equal to 0 plus x. This rule is known as the existence of additive identity. The additive identity is 0. Whenever we add 0 with any numerical value, the answer will be same, and x plus 0 is equal to x is equal to 0 plus x. In both the ways, if you add, the answer will be the same value itself. This is known as existence of identity. Now, x plus minus x is equal to 0 is equal to minus x plus x. So, this law is known as the existence of inverse. The additive inverse of x is minus x. So, these four laws for addition is held by the variables. That means because variables are numerals. Now, these laws are also true for multiplication also. For example, x, y is equal to yx, commutative law. Then, x, y into z is equal to x into yz, that is associative law. Then x into 1 is equal to x is equal to 1 into x. We know that 1 is a multiplicative identity. Therefore, x into 1 is equal to x is equal to 1 into x, and x into 1 by x is equal to 1 is equal to 1 by x into x. That is the existence of multiplicative inverse or the reciprocal. 1 by x is the multiplicative inverse of x, and also this the multiplication obeys one more law, that is x into y plus z is equal to xy plus xz. This is known as the distributive law. So all these laws hold for variables because variables are also numerals. Therefore, a collection of constants and variables connected by two or more operations is known as an algebraic expression. For example, 2x plus 5. This is an algebraic expression. We have a variable x here and two constants 2 and 5. Now it can be obtained. It can be explained like this. This expression can be obtained by multiplying x with 2 and adding 5 to it. So this way this expression is obtained. And now another one, 4x minus 3. Here 4 is x is multiplied by 4 and then 3 is subtracted from the product. So this way the expressions can be explained. Any algebraic expression will have its own explanation. So 2x plus 5 and 4x minus 3 are few examples for that, and they contain only one variable. We can have algebraic expressions containing more than one variables also, and we can have algebraic expressions with many powers like x square, x cube, x to the power 4, or y square, y cube, etc. So these are some examples. Another example, 4x square minus 2x plus 5, or 3x plus 2y. These all are examples of algebraic expressions. Now, what are the terms of an algebraic expression? We can understand what are the terms of algebraic expressions. Let us consider an algebraic expression, 2x square plus 3x minus 5. The various parts of an algebraic expression separated by a plus sign or a minus sign are known as the terms of the algebraic expression. For example, here we have 3 terms, because these 3 terms are separated by plus or minus. Therefore, the terms of this expression are 2x square, 3x and minus 5. These are the various terms of this algebraic expression. In this we have to note down one thing: multiplication or division cannot separate terms. Here we have 2 and x square, 2 into x square. But 2 and x square are not separate terms. They form a same one single term, that is 2x square. And 3 into x we have, but we write 3x as the same term, and also we have 5. Now, the parts of the algebraic expression separated by multiplication symbol, that they are known as factors. Each term can have their own factors. The factors of 2x square are, it has got 3 factors. You know that 2x square can be formed by 2, then x, and again x, 2 into x into x, x into x is x square, and then multiplied by 2, that is 2x square. So these are the factors of the particular term 2x square. Similarly, we can take out the factors of 3x and minus 5. So these are the factors and these are the terms of the given expression. Now let us see what are coefficients. Any factor of a particular term in an algebraic expression is known as the coefficient of the remaining factors. For example, let us consider an algebraic expression, 2x square y plus 4x. Now, in this expression let us consider the first particular term. In this term, if we consider y, if we want to find out the coefficient of y, the coefficient of y will be coefficient of y is equal to 2x square. Similarly, coefficient of x square is equal to 2y, etc. So this way, or if you want to find out the coefficient of x square y, it will be 2. So in this way, we can find out the coefficients of a particular factor in a particular term. Now, similarly, we can find out the coefficient of x in 4x also. The coefficient of x in 4x is 4. Here, the 2 is known as the numerical coefficient, and the other coefficients, 2x square or 2y, are known as the variable coefficients because they contain variables. Now let us see what are like and unlike terms. The terms having same variable factors are known as like terms. For example, 3x square y and 4x square y. These two terms have same variable factors x square y with the same power for each variable. That is also very important. X square y and x square y, they are like terms. Similarly, we have 4x and minus 2x. These all are like terms because they contain same variable factors. So they are like terms. Now, the terms that have different variable factors are known as unlike terms. For example, 3x cube y and 4xy. These are unlike terms because the powers of, though there are xy and xy in both the terms, the powers of x are different. So they are unlike terms. And also we can have 4x. This is also an unlike term because here we have xy, here we have only x. And we can have 3x square. So like that we can have different unlike terms. Remember, in like terms, the variables, there will be same variables and also there will be same powers for each variable. They are known as like terms and these are known as unlike terms. Now let us see what are the different types of algebraic expressions. On the basis of the number of terms, there are different types of algebraic expressions. An algebraic expression that contains only one term is known as a monomial. A monomial contains only one term. For example, 3x square. This is a monomial. Now, an algebraic expression that contains two terms is known as a binomial. A binomial contains two terms. We can write 2x plus 5 is an example of a binomial. Now, an algebraic expression that contains three terms is known as a trinomial. A trinomial contains three terms. For example, 3x square plus 2y plus 4 is an example of a trinomial. And an algebraic expression that contains more than three terms are known as multinomial. Multinomial can have more than three terms. Example, 4x square plus 2xy plus 3y square plus 5 is an example of, or it can have more terms. They all together are known as multinomials. Okay. Now let us see what are polynomials. An algebraic expression is said to be a polynomial if the powers of its variables are whole numbers. Let us see an example. 3x square minus 4x plus 5. Here we can see the powers of x are here. X is the variable. Here the power of x is 2. Here the power of x is 3. And here the power of x will be 5 into x to the power 0. We know that x to the power 0 is 1. Therefore 5 into 1. So here the power of x will be 0. So in this all the powers are whole numbers. Therefore it is a polynomial. Now let us consider another algebraic expression. 4x square plus 2 by x plus 5. In this, here the power of x is 2. Here what is the power of x? Here by using the law of exponent we have to take that 1 by x, that is equal to x to the power minus 1. So this will be 2 into x to the power minus 1. Therefore the power of x is not a whole number, it will be a negative number. Therefore this cannot be considered as a polynomial. So that is the difference between a polynomial and an algebraic expression which is not a polynomial. In a polynomial, the powers of the variables are always whole numbers, but in an algebraic expression, if the powers are not whole numbers, it is not a polynomial. Here these are polynomials in single term, single variable, that is x. We can also have polynomials in more variables like 3x square plus 2xy plus 5. This is a polynomial in two variables, x and y are the variables. And we can also have more than 2 variables in the polynomials. Now what is the degree of a polynomial? The highest power of the variables in a polynomial is known as the degree of the polynomial. For example, in this we have the power of x is 2. So 2 is the degree of the polynomial 3x square plus 2xy plus 5. Now in the first polynomial we have 3x square minus 4x plus 5. In this the power of x, first term the power of x is 2 and in the second term the power of x is 1. The highest power is 2, therefore the degree of this variable is this polynomial is 2. This is not a polynomial, so we don't have to find the degree of this polynomial. And in this, if we consider, suppose we consider this algebraic expression as this polynomial as 3x cube. Here 3x cube plus 2xy plus 5. Here the highest power is x cube. 3 is the highest power, therefore its degree is 3. Now when we find out the degree of the polynomial, if there are more variables in a particular term, we have to add the powers of all those variables. For example, if we have a polynomial 2x square y square plus 4x cube plus 5. In this, here we have x square y square. 2 variables in this term, and here we have only 1 variable. Here the total power is 3. But here the total power of both of these variables is 2 plus 2, that is 4. Therefore, the degree of this polynomial is 4. Now, exercise 8.1. The first question is to form algebraic expressions from the given statements. In that first question, 6 more than thrice a number x. Here the variable's name is given, that is x. We have to frame the algebraic expression here. Thrice a number x, that means 3x, and 6 more than thrice the number. So 3x plus 6 is the required algebraic expression. 6 more than thrice the number x. Now the third question, the numbers x and y squared and added. When x is squared, you know that it is x square, and when y is squared, you know that it is y square. So x and y are squared and added. Now number 7 is added to 3 times the product of p and q. So here we have to first of all consider the product of p and q. So that is pq. Now 3 times the product of p and q, that is 3pq, and 7 is added plus 7. So 7 is added to 3 times the product of p and q. So these are the required algebraic expressions in the first question. Question 1, 3 and 4 are solved here. Rest you can solve by yourself, frame the formula by yourself. Now question number 9. Here a term is given minus 7x y square z cube and some factors are given. We have to find out the coefficients of those factors. The first one is 7x. So what is the coefficient of 7x? Whatever factors which are other than 7x in the given term, that is the coefficient of 7x. So minus then y square z cube. We have minus y square z cube has the coefficient of 7x. Now minus x y square. Minus is given x y square. What is remaining? 7 is remaining. Then z cube. So 7 z cube is the coefficient of minus x y square. Now x y z. Here we have x y one time and z once. That means what will be remaining? Minus 7. Then y square. From y square we have 1y over here. That means 1y we have to write here. From z cube we have 1z here. That means z square. So minus 7y z square is the coefficient of x y z. Now 7y z square. 7y z square. So here we have to take minus in the coefficient. Then x is not in the given factor. So x we have to take minus x Then from y square we have 1y over here, and so 1y we have to write, and we have z square and in this z cube. So 1 z also we have to write here. So these are the coefficients of the given